Cubes. We have learnt in our previous classes that volume of a cube of side A is equal to A into A into A, which is equal to A cube. This shows that when we multiply a number by itself 3 times, the product so obtained is called the cube of the given number. The cube of a number is the number raised to the power 3. The cube of 2 is equal to 2 raised to power 3, which is equal to 2 into 2 into 2, which is equal to 8. The cube of 3 is equal to 3 raised to power 3, which is equal to 3 into 3 into 3, which is equal to 27. The cube of 5 is equal to 5 raised to the power 3, which is equal to 5 into 5 into 5, which is equal to 125. Cube of 1.1 is equal to 1.1 whole raised to the power 3, which is equal to 1.1 into 1.1 into 1.1, which is equal to 1.331. Cube of 4 by 7 is equal to 4 by 7 whole raised to the power 3, which is equal to 4 by 7 into 4 by 7 into 4 by 7, which is equal to 64 by 343. Perfect cube. We can see from above that 8, 27 and 125 are cubes of natural number 2, 3 and 5 respectively. We call such numbers as cubic numbers or perfect cubes. A perfect cube is a natural number which is a cube of some natural number. In other words, a natural number A is a perfect cube if there exists another natural number B whose cube is A. That is, A is equal to B cube. For example, 64 is a perfect cube because there exists a natural number 4 such that 64 is equal to 4 into 4 into 4, which is equal to 4 raised to the power 3. But 16 is not a perfect cube because 16 can't be expressed as a cube of a natural number. This shows that if a prime number m divides b, then m into m into m will divide b raised to the power 3. That is A. Check for perfect cubes. To check whether the given number is a perfect cube or not, we follow following steps. Step 1. Write the given number. Step 2. Resolve it into prime factors. Step 3. Group the prime factors into triplets of prime factors such that factors in each triplet are identical. Step 4. If after grouping no factor is left over, then the number is a perfect cube. Otherwise, it is not. Step 5. To obtain the cube root of the given number, we take one factor from each triplet and find their product. This product is the cube root of the given number. Example 1. Which of the following are perfect cubes? A. 8000, B. 400, C. 3375, NCERT. Solution. A. Resolving 8000 into prime factors, we have: on dividing 8000 by 2, we get 4000. On dividing 4000 by 2, we get 2000. On dividing 2000 by 2, we get 1000. On dividing 1000 by 2, we get 500. On dividing 500 by 2, we get 250. On dividing 250 by 2, we get 125. On dividing 125 by 5, we get 25. On dividing 25 by 5, we get 5. 8000 is equal to 2 into 2 into 2 into 2 into 2 into 2 into 5 into 5 into 5. Grouping into triplets of identical factors, we have 8000 is equal to 2 into 2 into 2 into 2 into 2 into 2 into 5 into 5 into 5. Because no factor is left, hence 8000 is a perfect cube. B. Resolving 400 into prime factors, we have: on dividing 400 by 2, we get 200. On dividing 200 by 2, we get 100. On dividing 100 by 2, we get 50. On dividing 50 by 2, we get 25. On dividing 25 by 5, we get 5. On dividing 5 by 5, we get 1. 400 is equal to 2 into 2 into 2 into 2 into 5 into 5. Grouping into triplets of identical factors, we have 400 is equal to 2 into 2 into 2 into 2 into 5 into 5. After grouping, 2 into 5 into 5 are left. Hence, 400 is not a perfect cube. C. Resolving 3375 into prime factors, we have, on dividing 3375 by 5, we get 675. On dividing 675 by 5, we get 135. On dividing 135 by 5, we get 27. On dividing 27 by 3, we get 9. On dividing 9 by 3, we get 3. 3375 is equal to 5 into 5 into 5 into 3 into 3 into 3. Grouping into triplets of identical factors, we have 3375 is equal to 5 into 5 into 5 into 3 into 3 into 3. After grouping, no factor left. Hence, 3375 is a perfect cube. Example 2. Is 1728 a perfect cube? What is that number whose cube is 1728? Solution. Resolving 1728 into prime factors, we have, on dividing 1728 by 2, we get 864. On dividing 864 by 2, we get 432. On dividing 432 by 2, we get 216. On dividing 216 by 2, we get 108. On dividing 108 by 2, we get 54. On dividing 54 by 2, we get 27. On dividing 27 by 3, we get 9. On dividing 9 by 3, we get 3. On dividing 3 by 3, we get 1. 1728 is equal to 2 into 2 into 2 into 2 into 2 into 2 into 3 into 3 into 3. Grouping 1728 into triplets of like factors, we have 1728 is equal to 2 into 2 into 2 into 2 into 2 into 2 into 3 into 3 into 3. Since after grouping no factor is left, thus the given number is a perfect cube. Taking one factor from each triplet, we have 2 into 2 into 3, which is equal to 12. Thus, 1728 is a cube of 12. Cube of a negative integer. The cube of a negative integer is always negative. For example, minus 2 whole raised to the power 3 is equal to minus 2 into minus 2 into minus 2, which is equal to minus 8. Minus 3 whole raised to the power 3 is equal to minus 3 into minus 3 into minus 3, which is equal to minus 27. Cube of a rational number. Cube of a rational number a by b. A by b whole cube is equal to a by b into a by b into a by b, which is equal to a into a into a by b into b into b, which is equal to a cube by b cube. Thus, a by b whole cube is equal to a cube by b cube. Properties of cube of numbers. A. Cube of an even number is even. For example, 2 raised to the power 3 is equal to 8. 4 raised to the power 3 is equal to 64. 6 raised to the power 3 is equal to 216. B. Cube of an odd number is odd. For example, 1 raised to the power 3 is equal to 1. 3 raised to the power 3 is equal to 27. 5 raised to the power 3 is equal to 125. C. Cube of the numbers ending in 1, 4, 5, 6 or 9 are the numbers ending with the same digit. For example, 11 raised to the power 3 is equal to 1331. 5 raised to the power 3 is equal to 125. 6 raised to the power 3 is equal to 216. 9 raised to the power 3 is equal to 729. 4 raised to the power 3 is equal to 64. D. Cube of the numbers ending in 2 and 8 are the numbers ending in 8 and 2 respectively. For example, 2 raised to the power 3 is equal to 8. 12 raised to the power 3 is equal to 1728. 8 raised to the power 3 is equal to 512. 18 raised to the power 3 is equal to 5832. E. Cube of the numbers ending in 3 and 7 are the numbers ending in 7 and 3 respectively. For example, 3 raised to the power 3 is equal to 27. 7 raised to the power 3 is equal to 343. Example 1. A. 2 by 7 whole raised to the power 3. B. Minus 4 by 5 whole raised to the power 3. Solution. A. 2 by 7 whole raised to the power 3 is equal to 2 raised to the power 3 by 7 raised to the power 3, which is equal to 2 by 7 into 2 by 7 into 2 by 7, which is equal to 8 by 343. B. Minus 4 by 5 whole raised to the power 3 is equal to minus 4 whole raised to the power 3, 5 raised to the power 3, which is equal to minus 4 into minus 4 into minus 4 by 5 into 5 into 5, which is equal to minus 64 by 125. Example 2. Find the ones digit of the cube of each of the following numbers. NCERT. A. 3331. B. 8888. C. 149. D. 1055. E. 1024. F. 77. G. 5022. H. 53. Solution. Using properties of cube of a number, ones digit of cube of A. 3331 is 1. B. 8888 is 2. C. 149 is 9. D. 1055 is 5. E. 1024 is 4. F. 77 is 3. G. 5022 is 8. H. 53 is 7. Example 3. Express the following number as the sum of odd numbers. 6 raised to the power 3 is equal to 6 into 6 into 6, which is equal to 216. Solution. 31 plus 33 plus 35 plus 37 plus 39 plus 41 is equal to 216. Cube root. Cube root. A number A is the cube root of a number B if B is equal to A raised to the power 3. The cube root of a number B is A, denoted by cube root B. Cube root of B. Cube root of B is also called a radical. B is called the radicand and 3 is called the index of the radical. A. 1 is equal to 1 cube. Therefore, cube root of 1 is equal to 1. B. 8 is equal to 2 cube. Therefore, cube root of 8 is equal to 2. C. 27 is equal to 3 cube. Therefore, cube root of 27 is equal to 3. D. 64 is equal to 4 cube. Therefore, cube root of 64 is equal to 4. E. Minus 216 is equal to minus 6 cube. Therefore, cube root of minus 216 is equal to minus 6. F. 8 by 125 is equal to 2 cube by 5 cube, which is equal to 2 by 5 whole cube. Therefore, cube root of 8 by 125 is equal to 2 by 5. G. 0.027 is equal to 0.3 whole cube. Therefore, cube root of 0.027 is equal to 0.3. To find cube root of a given number by prime factorization, A. Write the given number. B. Resolve into prime factors. C. Make groups in triplets of identical factors. D. Choose one factor from each triplet. E. Find the product of the factors obtained in the previous step, that is step D. F. This product is required cube root of the given numbers. Example 1. Evaluate cube root of 125. Solution. By prime factorization we have, on dividing 125 by 5, we get 25. On dividing 25 by 5, we get 5. On dividing 5 by 5, we get 1. 125 is equal to 5 into 5 into 5, which is equal to 5 into 5 into 5. Cube root of 125 is equal to 5. Example 2. Evaluate cube root of 2744. Solution. By prime factorization, we have, on dividing 2744 by 2, we get 1372. On dividing 1372 by 2, we get 686. On dividing 686 by 2, we get 343. On dividing 343 by 7, we get 49. On dividing 49 by 7, we get 7. On dividing 7 by 7, we get 1. 2744 is equal to 2 into 2 into 2 into 7 into 7 into 7, which is equal to 2 into 2 into 2 into 7 into 7 into 7. Cube root of 2744 is equal to 2 into 7, which is equal to 40. Cube root of a negative perfect cube. Let m be a positive integer, then the additive inverse of m, that is minus m, is a negative integer. We also know that minus m whole cube is equal to minus m cube. Cube root of minus m cube is equal to cube root of minus m whole cube, which is equal to minus m, which is equal to minus cube root of m cube. Example. Find the cube root of minus 125. Solution. Cube root of minus 125 is equal to minus cube root of 125. Resolving 125 into prime factors, we have 125 is equal to 5 into 5 into 5. Therefore, cube root of 125 is equal to 5. Therefore, cube root of minus 125 is equal to cube root of minus 5 into minus 5 into minus 5 is equal to minus 5. Cube root of product of integers. Cube root of xy is equal to cube root of x into cube root of y. Example. Find the cube root of minus 343 into 9261. Solution. We have cube root of minus 343 into 9261, which is equal to cube root of minus 343 into cube root of 9261, as cube root of xy is equal to cube root of x into cube root of y, and cube root of minus x cube is equal to cube root of minus x whole cube. Resolving 343 and 9261 into prime factors. On dividing 343 by 7, we get 49. On dividing 49 by 7, we get 7. On dividing 7 by 7, we get 1. On dividing 9261 by 3, we get 3087. On dividing 3087 by 3, we get 1029. On dividing 1029 by 3, we get 343. On dividing 343 by 7, we get 49. On dividing 49 by 7, we get 7. On dividing 7 by 7, we get 1. Therefore, minus 343 is equal to minus 7 into minus 7 into minus 7. Therefore, cube root of 343 is equal to 7. Cube root of minus 343 is equal to cube root of minus 7 whole cube, which is equal to minus 7. And 9261 is equal to 3 into 3 into 3 into 7 into 7 into 7. And cube root of 9261 is equal to 3 into 7, which is equal to 21. Thus, cube root of minus 343 into 9261 is equal to cube root of minus 343 into cube root of 9261, which is equal to minus 7 into 21, which is equal to minus 147. Cube root of rational number. If a by b be a rational number, then cube root of a by b is equal to cube root of a by cube root of b. Example. Evaluate a. Cube root of 216 by 125. B. Cube root of minus 343 by 512. Solution. A. Cube root of 216 by 125 is equal to cube root of 216 by cube root of 125, which is equal to cube root of 6 into 6 into 6 by cube root of 5 into 5 into 5, which is equal to 6 by 5, which is equal to 1 by 5. B. Cube root of minus 343 by 512, which is equal to cube root of minus 343 by cube root of 512, which is equal to cube root of minus 7 into minus 7 into minus 7 by cube root of 8 into 8 into 8, which is equal to minus 7 by 8. Estimation of cube root. Finding cube root by using cube root table. Find the cube root of A 7, B 70, C 700. A. Cube root of 7 is equal to
1.913
from cube root x column. B. Cube root of 70 is equal to cube root of 10 into 7 is equal to
4.121
from cube root of 10x column. C. Cube root of 700 is equal to 8.879 from cube root of 100x column. Example. Find the cube root of 5112. Solution. Resolving 5112 into prime factors. This is shown as, therefore, cube root of 5112 is equal to cube root of 2 into 2 into 2 into 3 into 3 into 71, which is equal to 2 into cube root of 639. Cube root of 639. Now, 630 is lesser than 639, which is lesser than 640. So, cube root of 630 is lesser than cube root of 639, which is lesser than cube root of 640. From tables, 8.573 is lesser than cube root of 639, which is lesser than 8.618. For a difference of 640 minus 630 is equal to 10, difference cube root is 8.618 minus 8.573, which is equal to 0.045. For a difference of 639 minus 630 is equal to 9. Difference in cube root is 9 by 10 into 0.045 is equal to 0.405 by 10, which is equal to 0.0405. Therefore, cube root of 639 is equal to cube root of 630 plus 0.0405, which is equal to 8.573 plus 0.0405, which is equal to 8.6135, which is equal to 8.613. Cube root of 5112 is equal to 2 into 8.613, which is equal to 17.226.